All right, so trying something a little different here and going through in a very deliberate way AI from the standpoint of grokking the overall process. Grok being a term that's had a few different spellings in the recent couple of years, but it's most known for meaning to fundamentally understand something, like down to its core, even to understand it with empathy, as if you were drinking it in. And considering the fire hose that deep learning AI overall is having, there is a thirst for knowledge, but it's also very overwhelming, to say the least. So the intent with these is to grok, however you want to spell it, with a K or a Q, biased for the Q piece, but in learning the actual high value information on what AI and all this stuff really is. Because to understand something fundamentally is to then know how quality is really defined, which helps alleviate anxiety around these things and more lends itself to really amplifying our human intelligence. And so when we think of AI, you'll hear this term a lot of times of neural networks. And that's by design, because classical machine learning, what previously was done really since the 1960s, was attempting to just write enough code that eventually we would engineer all the different equations, anticipate to be able to replicate the human brain, how we think, how we make decisions. That really is what artificial intelligence has been since its inception, really since like Alan Turing, of how can we replicate how people think, right? But it's been very difficult for so long due to just that process of that classical approach, in that you had to anticipate ahead of time. You had to engineer things ahead of time. And that's not really how the brain works. Right? It is these connections that we make, and we can't say for certain what sort of connection will end up occurring. But when we better understand how we learn and how we think about the world, that then we can better aim what the inputs are to then drive the best output. Think of it like learning styles. Some people say, I'm a kinesthetic learner, I learn by doing. Then that better activates the neurons in our brain to then actually intake the information in the most optimal way, the way that it's intended to, or if you're auditory, whatever it is. When we think of neurons, this concept on the top left here of in your brain and also throughout your body, we have these little bundles. Again, not need to go super duper technical here, but just think of these little bundles of these little nerve units, almost like wires going throughout the entire body. And they operate with electricity. Yes, that's right. Your body has tons of electricity in it, but it's supposed to, so it's right, all very normal. What will occur is that there's basically a threshold of voltage of that electricity. Again, very small amount, nothing to be concerned about. That your different neurons, again, broad generalization here, will end up relying on to know whether they should turn on or not. And that turning on, that meeting that threshold based off of the voltage, the amount of the electrical signal that are going through will dictate whether or not the wiring, the actual action, will occur or not. Think of it like somebody taps a little bit on your hand and it doesn't really hurt, doesn't really do anything. But if someone was to, say, take a hammer, you might see with your eyes that hammer incoming onto your hand and want to stop it ahead of time because that's triggered, that's reached the threshold of, okay, I need to take action. Or you touch a hot stove, that's reached that threshold of action. So too, then we see in neural networks, particularly what's called the transformer architecture, not Michael Bay, but this novel architecture, this structuring of these neurons of this AI system that was made by Google, and this very famous, and really highlighted in this very famous paper in 2017 called "Attention is All You Need," which there's more, but it's obviously a joke in there, but it took this framework, this architecture, and that's made of all these different neurons that on the bottom left you see here of all these different inputs that then end up all building towards this net or this overall input that then decides, with the addition of the bias here, which that's not bias like necessarily political bias, that's just each one of these input functions, each one of these weights that then goes from the inputs really carries it decides on how strong of a connection there may be, and based off of the input from another area. So think of maybe like cats, of whether or not it's a good or bad thing. Let's say has paws, has I don't know, meows as the second one, and you get the point. But these different inputs will then end up going in, and they're weighted, and they decide on when they end up getting input on whether or not that activation function gets turned on or not. And if it does, then that then sends signal to another neuron, so on and so forth. And those connections will then decide on whether or not in the activation of it, and again, we can't say 100% where and how each individual neuron will end up interacting, either in our own brains, right? We think of, how many times have you seen something and you're like, why didn't I think of this? It's for as much as we know about the brain, there's so much we don't know. But that same sort of functionality is being seen in real time with large language model, AI in general. Right? On pause because there's small language models, large, small multimodal models. It gets very complex very quickly. But the main takeaway is these AI models, particularly as we see them, they feel so human. They feel so like us, and sometimes it could even be understandably a little unnerving because they're built with the best possible understanding of how our own brains work. So it's seeing ourselves in a mirror because it's a bunch of these neurons. I'm sure there's going to be some, they're not really neurons. For simplicity's sake, neurons. And plus that is also typically folks within just the industry can refer to those. That's the shared language. But these neurons in whatever the large language model or AI model that you're using, and particularly within using, you'll see this whether it's PyTorch or TensorFlow, but typically it's most models, particularly on Hugging Face, on open source, you're going to see that are built with the PyTorch library, Python, PyTorch models. And regardless of the model that you're looking for, they're all at their core effectively implementing these neurons that have different weights, and that all end up connecting based off of the way it's been trained and the data set to make different connections that when new inputs get put into it, then will end up going and deciding with each neuron of, all right, I got these inputs. Does this input, or does this meet our threshold? Does this overall neuron turn on to then point to another neuron that makes another connection, or hasn't met the threshold? So for example of something that's, if a model has been trained, given all this data that cats are good, and it receives something about, hey, I think dogs are the best, well then it might not end up answering to the affirmative of dogs being the best, because the model has been given the data, has been trained on all the connections being optimized to cats being the best. So all those things with cats carry higher weight that then activate more of those functions. The things with dogs carry less weight, less value attributed to those different things, and then that will then drive how the model responds. So to Grok, this, and really Grok with a Q, is understanding that the hardware and the software, when they're optimized together, so software being these neurons that end up connecting, and understanding and appreciation of the math that goes behind it, which that was going to come out at a later time, but just know that there are these individual operations called floating point operations, or flops for short, and they're using, it depends what you end up asking. People say vector math, some people say linear algebra, we'll just say math. They're doing math because they are computing the different calculations on whether or not they're going to meet that threshold for activation on that neuron to neuron connection, and whether they're individual numbers, it's like scalars, or they're few numbers. It's like a vector, so think of like a direction. So I know it's like geometry and all this coming back together. Like, no, I thought I escaped. Then you end up having matrices, which are, arrays, so you can have multiple lines. Those things sort of like Tetris. And then all those fall within the camp of being we're called tensors, or they become these multi-dimensional, right? So they can be represented in this multi-dimensional space. And we think of like 3D, 4D, 5D, 6D. But they're taking this information, and now we're representing it in such a way where it's like multiple possible dimensions. And again, that reflect a lot of ways our neural network in our brain of all these big individual nodes that then end up being able to connect and then drive the processing of the input, which, whether that's the training or just your input for the inference, which is our output of what we are guessing as we're interacting with the world. So the big takeaway is any of these AI models, it's not magic. I feel like that sometimes. It's math. And we think of things as being deterministic. As the good folks at Groq will end up saying, it's understanding, removing as much as possible from understanding deeply the math that occurs and the way that these networks are structured, to then optimize the likelihood of getting the reliable answer that you're looking for, actual use case that you're looking for, because it's built from the ground up. So hopefully that this was helpful as just an initial broach into the topic of groking, how AI models work, how AI works, and really why we refer to them as neural networks. Again, it's not quick and easy of 10 minutes to understand AI. It's not about getting this single answer, but I think what I found helpful and what I would encourage folks is to view it as, what are you most interested in learning? What's the thing that gets you really into that flow of, right, the thing that drives you? And from there, you then can tie AI into it, because all AI is just, at its core, compressing intelligence, taking data, turning it into intelligence, and making that scalable. So hopefully this is helpful. And what's the YouTube thing to say? Oh, that's right, for the algorithm, like and subscribe. And yep, I will see you in the next one.